To the whole world, guys. In case you're curious what the heck is going on the screen right now, I just want you to know that, you see, I've got a lot going on in my life. You see, I've got my fingers in every pie, and that's one thing you've got to know about me, in case you didn't. Okay, by the way, what I do have right here on screen is actually my Spring Boots projects for my website. And right here I was, essentially what I was working on lately is to try to integrate my website with Spotify. That is to say, I'm trying to have access to your music, you guys, to your playlist, your favorite albums, so on and so forth. Okay, and this right here is the code which takes care of that. Oh, by the way, I am not done yet with it. Okay, of course, oops, you shouldn't have seen that. Okay, because that's my secret key. Okay, no one should see that. Okay, you know what? I'm gonna update it for those who are dumb enough to intrude with my access to Spotify. Okay. Anyways, you guys, that is not what we're working on. What I just mentioned is a horse of a different color. Okay, what we do have, or rather what we want to work on, what I want to work on at the moment is this exercise right here. I know that probably annoys you, and I don't give a ish, to be honest. That's my favorite. That's one of my favorite music by Penny, and I can't even understand what the guy is saying. But you see the instrument. Damn! Let's jump onto the problem on hand, you guys. I haven't yet opened the goddamn PDF. Really? Let me pause and do so. Yeah. I know you're probably pissed by now. You're probably thinking that I should have started already. Okay, now that I've opened my PDF, let me zoom in even more so that everyone can see. To be honest, you guys, this is one of those exercises that people supposed to try themselves, right? Without actually watching me going through them, right? Because there are a ton of exercises, trivial exercises that I've already done to wrap your head around the concept of multidimensional arrays, right? By now, you should know enough to do this exercise by yourself, okay? But you know what? I'm gonna do it anyways, okay? So it's a 9-cell program, okay? I'm confusing this with a different problem. Okay, ideally here we've got 9 coins, right? That are placed in a 3x3 matrix with some face up and some face down. Okay, you can represent the state of the coins using a 3x3 matrix with values 0 for heads and 1 for tails. Okay, so here are some examples. Okay, as you can see, so each state can also be represented using a binary number. For example, the preceding matrices correspond to the numbers, as you can see. Okay, so there are a total of 512 possibilities. So you can so that's ideally 2 to the exponent of what? 9, if I'm not mistaken. Yeah, 9. Okay, so there are a total of 512 possibilities. So you can use decimal numbers 01 up to 511 to represent all states of the matrix. Write a program that prompts the user to enter a number between 0 and 1 and 511 and displays the corresponding matrix with the characters H and T. So here is a sample run, as you can see. Okay, now that we've got that out of the way, is there anything else that I might be missing? Oh, perhaps let's read this bottom part. The user enters 7, which corresponds to that. So since 0 stands for H and 1 for T, the output is correct. Okay. I got that. Oops. Now let's jump on to it, you guys, without any waste of time. Now, why is my IDE not responding? Matter of fact, we need to create a scanner, which I should have taken care of before I start recording. Now I wanna go system.out. Oops. Print. Enter a number. Of course, we need to store that number. I'm gonna use a short data type. A number, and I'll go scanner.next short. Of course, I wanna validate my user input. The only valid numbers are those that are between 0 and what? Those that are between 1 and 512. Right? Is number less than or equals to 512? And I want to make sure that number is less than or equals to what? 1. Greater than or equals to 1. If this is indeed the case, then we're good. That's where we'll be creating the 2-dimensional arrays of what? Of booleans. So it's gonna be a 3 by 3 matrix. You know what? Now I need to create 2 methods. The one called create grid, which will create grid for me. Of course, I could do this right here, but I don't want to. So I'm gonna put it at the bottom. Public static void create grid. This will take as argument, it will take a grid and the number. Okay, so that's my first method. My second one will be responsible for displaying like static void display. This is the one that should display our matrix. Grid. Okay, Now let's suppose we already have the implementation of those two methods. What we want to do is to create grid. We want to create our grid first. We'll pass it grid and number. Once we're done doing that, we'll display our grid. I'm hoping everything is clear up to now. Excuse me. Okay. This is in system.error dot print. I wanna print an error message. Fuck. Why are you messing with me? So the error message will simply go error invalid number. Okay. Now let's jump on to the implementation of our let's start with the create grid method. Okay, I'll simply go short sum. This will be useful later on, and I don't want to talk much because I feel like I'll be creating even more confusion. I need another variable called exponent. We're gonna start from 8. Ideally, why 8? We wanna start from we will be having exponents starting from 0, 1, 2, 3, 4, 5, 6, 7 up to 8. That's why we have 8 there. Okay. Now we need a variable that will be useful for determining whether or not to keep modifying our grid. Again, that creates confusion. Maybe later on you will understand, you guys, if you lost at the moment. Okay. Now let me have an outer loop. Bytes I is equals to 0. Now is I less than grid dot length, and and we're not finished yet. We're not finished yet, right? So we're gonna go I++. As for our inner loop, J is equals to 0. J less than grid. Of course, we could simply put 3 here, guys, but I'm not going to. Okay, so J++. Really, I missed that. Okay, now I want to check if my sum plus 2 to the exponent of exponent, I want to check if that is less than my number. You see, this tends to be clear if you're gonna sit down with the pen and the paper first, right? That way you're gonna have a well understanding of what's going on here. Without doing that, I hardly think things are gonna seem easier for you. Okay, enough words, let's continue. So it's gonna be if we're saying if sum plus math dot pow, we're saying sum plus 2 to the exponent of our exponent to the exponent of exponent. Oops. If that is what? If that is less than or equals to number, then we know that we can add 2 to the exponent to our sum. So I'll simply go sum, I'll add that. Let me put it this way. You see, oh gosh, really? You see, let's take this for example, right? I'm starting from left to right. I'm gonna check. Starting from left to right, I'm gonna check if 2 to the exponent of 8, which is what? 256, if I'm not mistaken. I'm gonna check if, you see, for instance, let me take this example here, what they gave us here. You see, 7 corresponds to that. Okay, so how am I gonna get this right here? I'm gonna start from the leftmost bit, okay, which is 0 in this case. I'm gonna check if, and my sum will be 0 initially. I'm gonna check if 2 to the exponent of 8, I'm gonna check if 0 plus 2 to the exponent of 8 is less than or equals to 7. And we all know that is not the case, right? 2 to the exponent 8 is 256. So that's a gigantic number. It's a huge number compared to 7. So I'm going to ignore that part. So I'm going to check now 2 to the exponent of 7, which is what? 128 plus 0. Is that number less than or equals to 7? Nope. So I'm going to skip that number. Now I'm going to check 2 to the exponent of what? 6, which is what? Which is 64. Yes, which is 64. And 64 again is greater than 7. So we're going to ignore that. And same thing applies for the next bit. We're going to check if 2 to the exponent of 5, which is 32. We're going to check if sum plus 32, which is 0 plus 32. We're going to check that if it is less than what? If it is less than 7, and that is not the case. We all know that. Now we're checking 2 to the exponent of 4, which is 16. We want to check if sum, bear in mind, you guys, our sum so far is 0. So we're going to go 0 plus 2 to the exponent of 4. So 0 plus 16. Is it less than 7? The answer is no. So we're going to skip that. Now we're checking 2 to the exponent of what? Of 3. Now, which is 8 plus 0. Is 8 plus 0 less than 7? The answer is no. We skip that again. Now we're checking 2 to the exponent of 4. That's for our third last bit. We're checking 2 to the exponent of 4. We're checking sum, which is 0. We're checking 0 plus 2 to the exponent of 4. 2 to the exponent of 3. We're checking that now. If that is less than or equal to our number, we're gonna consider that bit. Otherwise we're gonna ignore it. Okay, it turns out that we're not going to ignore 2 to the exponent of 3. Oh wait, is it 2 to the exponent of 3 is 8. So that 8 plus 0 is greater than 7. So we're gonna skip that. Now 2 to the exponent of 2 is 4. So 4 plus 0, which is our sum, the 4 plus 0 is 4. So okay, since it is a number less than 7, we're gonna consider that number. Okay, so we're not skipping 2 to the exponent of 1, meaning that we're gonna have a 1 on the third last bit. Okay, now our sum needs to be updated, and it's gonna be 4, right? Now we're checking 2 to the exponent of 1 plus our sum. Our sum so far is what? Our sum is 4. So it's going to be 2 to the exponent of 1, which is 2. So 2 plus 4 is that number less than 7. The answer is yes. We're going to update our sum. So our sum now becomes 6, right? Now we're checking the last number, the last bits, the rightmost bits. In this case, 1. Okay. On this right here, this is what I'm talking about. Okay, now we're checking, is 6 plus 2 to the exponent of 0, which is 1. Is 6 plus 1 less than or equals to 7? And the answer is yes. So what we're going to do, we're going to update our sum. Our sum is going to be 7 now, which is the exact number that we want. Now, enough words, you guys. I know maybe I created even more confusion there, but now hopefully by coding things will make even more sense. Okay, now we're saying sum plus 2 to the exponent of exponent. If that number is less than or equals to number, we update our sum. We update the corresponding value on our grid array. So it's gonna be I, J. We turn it. It's like turning from 0 to 1. Okay. Now if sum is exactly equals to number, we want to say that we finished, because we don't want to go all the way from left to right. We don't want to go all the way once we have once our sum has reached number, right? We want to stop immediately once our sum is equal to number. So I'm going to update my finished variable to true, and I'm going to break. Okay, that's pretty much it, you guys. Oh, what do I want to do? That's pretty much it. As for my if statement, what do I want to do on each iteration of my inner loop? I want to update my exponent. So we're starting from 8, so it's gonna be 7, 6, 5, 4, all the way up to 0. That's gonna be it for our outer loop, you guys. That's for our method, I mean. Okay, now let's go to the last part, which is where we're displaying public. Oops. Really? I will simply go. Of course, I do need to use nested loops. This is I less than grid.length I plus plus for bytes. I is I less than, J this time around. Is J less than grid? Come on, there's nothing wrong with using grid.length here, because we know that we have perhaps, you know what, let me just do that. Okay, J plus plus. Now what do I want to do is to check if we have true on a given grid value. If the grid value is true, then we know that we need to display 1. We need to display t, I mean not 1 or 0. T, and then we leave a space. Otherwise, we need to display F. This is the trivial part, you guys. Here we go again. The stupidest IDE is down. Okay, it's F. Perhaps I shouldn't have put those there. Okay, only thing left for me to do is to go to the next line. Done, you guys. Problem solved. You know what? It's time for me to do the checking. It is time to test my code. Bear in mind, guys, I'm not concerned at all about the efficiency, nor am I concerned about the effectiveness of my program. As long as it works, hopefully you would have. Why is it? It's running and yet, fuck, it's super slow. Let me have a sip then. Which is the exact thing they have here, you guys. Let's try a different number, like what? Hello. Let's try a different number, like 50. So it's gonna be starting from left to right. So it's gonna be the top left value. We're starting there all the way up to bottom right. Okay, so it's gonna be to the exponent of 8, which is 256. No, we don't want that. We don't want 1. We don't want 1. So it's 256. No, we don't want that. We don't want. Okay, what we do want. So we want 2 to the exponent of 0, 1, 2, 3, 4, 5. So 132, that's why we have a t there. We also want 16. So 32 plus 16 is what? It's 48. Nope, really? Yeah, it's 48. We don't want that. So far we've got 48. We don't want that either, but we do want 2 to the exponent of 1. So 48 plus 2 is gonna be 50. As you can see, you guys have a working solution, but then again, feel free to identify any mistakes or logical errors you might probably see. Cheers, you guys. I'm gone.